Well, hello from Emerald Hill Skies. My name is Doug. I'd like to welcome all of you here. We've got several on the stream already. Tiffany, you're always good about welcoming everybody. That's kind of you to encourage me about the hosting, but really I think about you as the one who are hosting, and I'm just kind of opening up a portal for you. I'm going to check this audio, make sure that that's running okay. Make sure you've got audio here. Yeah. And Larry, good to have you on board from Kentucky. Dennis, good to have you as well. Dave Durfee, good to have you. I don't remember where you're from, Dave. You might tell us where you're logged on from. We're going to do several things tonight. One of the things I thought we'd start is just to take a look at maybe NGC 11, see, is this 1173? Let's get our deep sky image annotation on here. Let's see, right here. Yeah, 1183 right here in the middle, that tiny little galaxy there. I'm going to zoom in just a little bit more, even though it's past our level of optical zoom. And that's a tiny elliptical, I believe, right there, 1183. And then here's 1177. This is 1175. It's a galaxy cluster. Let me go ahead and take deep sky image annotation off for a second. You can see some tiny galaxies there. You might be noticing a little bit of difference in our screen, the way we're set up. And I'm just going to try this for a while. I did a little bit of reading this past week about dark themes on computer applications. And here I thought they were easier on your eyes. But the more I read, the more I learned that actually, because your eyes then open up wider, you know, the iris of your eyes will open up just like a 35 millimeter camera, it means that that you're using more of your lens and there's less depth of field, and you actually strain a little bit to be able to focus, I'm told, by these researchers. Whereas when you make everything a little bit brighter, your eyes shut down a little bit more, you use the center, and just like with a 35 millimeter camera, you've got more depth of field when the image is actually stopped down a little bit, and you can actually see better for longer. So I'm going to try this, see what you guys think. Love to hear your feedback about it as well. Let's widen out here a little bit and look at the whole image and turn on our deep sky image annotation one more time, because there are a couple of other images here we're going to try to zero in on. I'm going to just make the sky a little bit darker. So here's ICO 284 here and NGC 1198 here. This is from Phil Harrington's book, Cosmic Challenge, the book that we've been working through off and on between things. Try to get that in focus for you. There we go. Cosmic Challenge. And what he does is he labels his challenges with a number. So you'll hear me say like Cosmic Challenge 167. And the name of this particular object, or cluster actually, is the Able Galaxy Cluster 2151. And it's just a whole collection. It's the richest member of the Hercules supercluster. And the entire area is just 1 degree across. That's crazy, isn't it? Just in 1 degree, you can have, I bet there are 20 galaxies here. And it's part of what's sometimes called the Great Wall, not the one in China. He helps you identify these one at a time. I'll put this in perspective. This is the list of galaxies you can see from this screen. Look at that. I mean, it even continues on the next page. Way more than what Robin has here in SharpCap in the deep sky image annotation. He goes through these one at a time, and each of these galaxies is an incredible, like 100,000 light years across galaxy. They're all around magnitude 15-ish, 15 or 16. And I think I'll just click off our observation here. You might be noticing that we're using a different observing software. So I'm just trying to make sure I've got everything done correctly. I think I do. You know, the crazy thing is, this past week I tried another observing software called the Sky X, and I'm going to turn this mic down just a little bit. It looks like it's over-modulating just a little bit. I'm going to bring that down if I can get it to cooperate with the program. Oh, there we go. Maybe down to about right there. Check 1, 2. That looks a little better. So in the process, I started studying through the Sky X that I've been using, and I'd also been using Sky Tools. And boy, the more I looked at them, the more I realized there were weaknesses in all those that I didn't like, and especially if I wasn't going to worry about the beauty of a night vision mode. I just was attracted back to Astroplanner. I know that's crazy. You're all going to think I'm crazy, but it's just so easy, and you can add fields to it endlessly. I came back to it. I caught it all up in terms of the number of observations, and I just realized, man, it's like putting on an old pair of jeans. So I'm back with Astroplanner. We'll talk about that a little more throughout the rest of the night. Let me catch up with you guys over here. Two Rivers Observatory, welcome. Rural Colorado, that's Dave Durfee. Yeah, good to have you aboard, Dave. Tiffany says that would be beautiful. Way up north by the Nebraska border, near Sterling Reservoir. That sounds really beautiful. Okay, so I tell you what, we're just going to turn off live or deep sky image annotation one more time and zoom in here a little bit more one more time just to make sure that we've caught all these little tiny galaxies. They're just one after another here, one collection after another. And I think there's another one right there. I think you get the effect of this entire cluster of galaxies. Okay, well, we said we'd go to the moon tonight, so let's head on over to the moon. I was just doing this for a little warm-up before you guys came on. So let's head on over there. I'm going to, on our sequencer, I'm going to turn to there, and then I'm going to turn our here we go. I think all I have to do is do that. Okay, so it should be slewing there. Now, I went over several maps of the moon that you guys might want to try. And I already put them in the description. One program I found that was called Virtual Moon, oh, what was it? It's in the description. Virtual Moon Atlas. And I give you the website and a little bit about it. I think that's really one option. How do I get comments back now? I lost you guys. Here we go. There we go. Virtual Moon Atlas is one option. So I'm going to go ahead and bring that up just so you can get an image of it here. Virtual Moon Atlas. You can see over in the sky cam here to the right, you can see how bright that moon is. It's illuminating our telescope just like it's daylight out there, isn't it? There's no light on that telescope. That's just the moon. Pretty crazy. Okay, so here's virtual Moon Atlas. And let's zoom in here a little bit. Okay, so let's just get a picture here, and then we'll also go over to our, boy, that's going to be bright. So sorry. You know, I think we'll just bring this stuff to a close and set this on about 0.3 seconds. Turn the gain down to 100. And then not enough stars because the moon is so bright. So how are we going to do this? Let's, how are we going to find the moon since we can't plate solve? I'm not used to using these little arrows here, but it looks like that's what we're going to have to do. Let's see. So I think it would be let's go back to our sky cam here. Looks pretty centered home. I wonder, I've never used this little spiral thing. I don't know if you guys have ever noticed this, but it's supposed to take the mount in a little spiraling search from where you are, keep working its way outward. So let's try that. Maybe I should make this 1 second for right now. Oh, there we go. Can you see it down there? In the lower left, huh? Let's go, now to go down, I think down would be that way. So let's go a little bit to the left. What's my rate here? 8? Let's put it on 16 and go a little bit this way. Is it moving? Didn't look like it moved that much, did it? There we go. There we go. Can you see it moving? Okay. Now, now I wonder if I'm going to do the right arrow or the left arrow. Because you see the mount is always kind of on its side. What is the deal, man? That's so odd, isn't it? It almost looks like we're looking through a tree, doesn't it? But we can't be. Look at where the scope is. What in the world is that? We must just be... Let's go somewhere else first. This is crazy. Oh my goodness, thank you, Astro Duck. I have no idea what's going on here. Let's go to another object and sync our mount with that object. Let's go to, well, all these are so close to the moon. Let's try going to something like that's at 13 degrees, pretty low. 24, that'll do. Let's go there. This is just too weird. It looks like we're looking through trees. Oh, there was the moon, huh? I guess because it's a full moon tonight, it looks so bright. Yeah, Larry, EAA works with a full moon. It's just we couldn't plate solve with a full moon. Okay. Looks like it's settled. Now let's go back to 400 here with our, and 3 seconds again. And then now let's plate solve. And we'll see what we're doing is when we plate solve, we're teaching them out. See, it was off by 0.67 degrees. Let's go one more place here. How about this is a 27. It's a nice double star there, isn't it? It's beautiful. Let's go one other place we can teach the mount where it should be. Thank you, David, for being here with us. We have the coordinates for the moon, Dennis. It's just that when we got there, we needed to plate solve to teach the mount where it was. So this is going to the little beehive, M41. And hopefully with these extra little stopovers for the mount, I think that's the little beehive right there in the middle. We will have taught the mount where to go. We can go back to the moon. Yeah, just a tiny little correct. Oh no, that was 1.3 degrees off there. There's the little beehive. M41. Okay, now let's go back up to the moon and hope that we're a little closer this time. Isn't that funny that when you're not out there at the scope? Okay, so we're going to go right here. Astroduck, it's so cool that you're willing to pitch in. You guys saw that he pitched in like toward the whole thing, and anything that's given, we of course try to use it for the good of the cause of somebody that needs some help somewhere. And we've helped over the past few months. We've helped folks in Afghanistan and Turkey. We've helped folks in Morocco with a quake there. And so with this one, we'll probably try to get this toward maybe people that are having a hard time in Sudan. That's been on my mind lately these past few days. I saw, boy, that's bright, isn't it? I saw just this past week that only 5% of Sudan can afford to have one meal a day. So 95% can't even afford to have one meal per day. Well, there's the moon over there to the right again, but maybe we're a little bit closer. Now I need to get better at these arrows, figuring out which arrow is which. Did that go the wrong way? I think it did. Let's try going this way. There we go. It's definitely very bright, isn't it? Oh, I'm saving your eyes because you're looking at the scope, and you're not missing much, by the way. Okay, so if left went that way, then I think this way must be up. Nope, the other way must be up. It's kind of like, it is, Tiffany, you're right. It's a shocker, she said. Okay, so up is to the right. Okay. Now I'm just going to try to get a decent this thing is so bright. Try to get a decent view here. Wow, so we're at 1 millisecond. Okay, so here's our live view of the moon tonight. Man, it's beautiful, isn't it? For being such an enemy of the state, let's see, we're going to go to 80. See, that was 1 millisecond, I think. Let's try that again. 1 millisecond. So let's go with 0.5 milliseconds and see how dark that gets. It's a little bit too dark, isn't it? How about 0.7 milliseconds? Getting this timing right. Two Rivers, you're asking, Stan, you're asking about the Messier Marathon. I don't know, I've gotten so spoiled with you guys taking time to look at things. I've done the Messier Marathon the last 3 years, and we got all 110 objects the first 2 years. Last time I did it, just, we did it on here with this being the only telescope. I think we got 109 objects out of the 110. So we got all but one, just missed with M30. But I didn't really enjoy having to go so fast. You don't get to enjoy seeing things. And so I'm not real sure if I'll do it. But I guess, if you guys want to, we can. We can do it again. Good to have you aboard, Ray. Family birthday party, just getting home. You didn't miss much. We just did a few objects to get warmed up. All right, so let's now go over to our atlas. Let's see. Here's the atlas. And let's see how we compare. Okay, so see how these mare, as they call them, it's turned by a right angle, isn't it? So let's see, how can we fix that? Somewhere here we go. Rotate north, south, flip east, west. So this is $90 degrees. We want to go 90 degrees counterclockwise. I don't think they let you do that exactly. They don't let you turn it like that. We can go like this, That's not going to help us. And then we can flip it north-south. That doesn't help us. What does this do? Full globe. That doesn't help us. Well, let's just put up with it being 90 degrees off for now, because we can't rotate this either. All right, so look at this thing that looks sort of like the Pac-Man. And then it's got a giant wheel here. Okay, now we'll go to the one that's the map. So here's the Pac-Man, and here's the giant wheel. You with me? Okay, then look how we've got, would this be like a giant shark mouth that's about to eat the Pac-Man? Giant shark's mouth. So here's the giant shark's mouth that's about to eat the wheel and the Pac-Man. Okay, so let's get oriented. So above the Pac-Man is Mare Crisium. So this is Mare Crisium. This is our live view, and we're at 700 milliseconds. Very short exposure, and the gain is 100. So what is this? You guys remember? Mare Crisium, C-R-I-S-I-U-M. Mare Crisium. It means, so what I've done is I've clicked on Mare Crisium. The name is Sea of Crises. It's because it's about to get eaten by this big shark's tooth. Okay, now underneath you've got Mare Fecunditatis. So this is Mare Fecunditatis. Right underneath, remember what this one is? Mare Crisium, right? Yeah. Mare Fecunditatis is the top part of the Pac-Man. And then this bottom part is Mare Nectaris. Mare Nectaris, like nectar. See where that name comes from. Sea of nectar. Fecunditatis, that means sea of fruitfulness. So there's the sea of fruitfulness, the sea of nectar, the sea of crises. Now this is the sea of tranquility. So this would be the sea of tranquility. And do you remember that famous line that our astronauts said when they hit the surface of the moon? They said, "Tranquility Base." Remember that? Okay, so let's go to object number 46 in the Cosmic Challenge. Cosmic 46. And sure enough, object 46 is Apollo landing sites. Okay, so you've got the Sea of Fruitfulness, Mare Fecunditatis, the Sea of Nectar, Mare Nectaris, the Sea of Crisis, Mare Crisium, and here the Sea of Tranquility, and right here was where Apollo 11 landed. So we're going to go to the place where Mare Nectaris bridges into the Sea of Tranquility, and as we go from Mare Nectaris to the Sea of Tranquility, we're going to take a left, and right around that little peninsula, that's where the Apollo 11 first ship on the moon landed. So let's go back to our screen. Mare Fecunditatis, Sea of Fruitfulness, Sea of Nectar, Sea of Nectar coming up into the Sea of Tranquility, and right here. Now let's zoom in a little bit. Can I Yes, I can. So there's a little white thing right there, see? And that little white thing is probably just, well, let's go back over to our map because it would show it. Right here. What we're seeing there is the Moltke crater, Moltke. Now to give you a sense of size, Moltke crater is 4,000 feet high. So what would that be? 3/4 of a mile. And it's 4 miles wide. So right there, Moltke crater. Now let me mark that one more time, and everybody remember where that is. And then I'm going to turn off the labels so that you can see it a little better. See there's a little red dot there? I'm going to click onto another thing so you can see that little crater. See where my crosshair is? Right here. That little crater is 4 miles wide. Now when we go back over to our live view, you're seeing that little crater right there. And what you're seeing is just the sun reflecting off the difference in it, which to me is amazing. That as you look at the moon, which is what? 240,000 miles away, I forget. Maybe somebody will look it up for us. I think it's 240,000 on average. At 240,000 miles, you can see an object that's 4 miles wide pretty easily. I think that's so cool. And very near that little crater, Moltke crater, is where Apollo 11 landed. Now, I don't think this program has Apollo 11's site marked, but Harrington does. You can see if I can get it in focus for you. Hello. Hello. Here we go. Right there is Apollo 11's landing site. It's right on top of Moltke crater. So I think that's pretty cool that you're looking at a crater that's 4 miles wide. You can almost wish that you can see the glint off of the lunar module sitting there, can't you? But not. And here we are in the live view, and you're seeing it right there, a little reflection off that 4 mile wide crater. Sea of Nectar. Oh, yeah, here, I'm sorry. Yeah. Seeing it right there. Pretty amazing. Okay, so that's Apollo 11. The next ship was Apollo 12. So let's work our way over. Well, you know what? Let's catch Apollo 16 while we're here. Apollo 16 landed let's see. You can also go up here and you could put in Theophilus and it'll take you right to it. So let's put the labels back on. So there's Theophilus, and then next to it is Cyrillus crater, and Apollo 16 landed right here in this area right here. So again, not that far away from where Apollo 11 landed here. Here was Apollo 16. Then Apollo 17, not that far away either. It was right in front of Taurus, the Taurus Mountains. So let's put up here Taurus. Taurus. Right here is Taurus Mountains. So you know, here we are, the Sea of Tranquility. So here's where 11 was. Here's 16. And 17 landed right here between the Sea of Serenity, Mare Serenitatis, and Mare Tranquillitatis, right here in front of these mountains was Apollo 17. So let's go over and find this now. Here's Nectar, Tranquility, Serenity. Right here is where Apollo 17 landed, and 16 was down here. Let's see, the Theophilus and Cyrillus. So right in here is where 16 was. Larry says there's a website that plays the comm from Apollo 11 in real time. You can listen to the whole mission. That's awesome. Dennis still remembers Apollo 11 evening they landed. How many times did Apollo 11 orbit the moon before they landed? Collins orbited a total of 31 times, Dennis says. You guys are doing all kinds of stuff there. Okay, so let's review. Mare Crisium, Sea of Crisis. Mare Fecunditatis, Sea of Fertility, was it? Sea of Fruitfulness. Sea of Fruitfulness. So, Mare Crisium, Sea of Crisis. Mare Fecunditatis, Sea of Fruitfulness. Mare Nectaris, Sea of Nectar. Mare Tranquillitatis, Sea of Tranquility. Apollo 11, Apollo 16, Apollo 17, Sea of Serenity. Mare Serenitatis. Going back to our map, this must be Lake of Dreams, Lacus Somniorum. So this is Lacus Somniorum, Lake of Dreams. Now this is our live shot, don't forget. So this is the real live view of the moon. I'm going to back off just a little bit so we can get our bearings again. We're using a RASA 11, if you wondered. RASA 11, that means it's 11 inches wide aperture, and we're using a ZWO ASI 2600 for our camera, and it's mounted there on the open end, the end that looks up in the sky. It's actually mounted at the top of the scope as if it would block. It blocks about 20% of the view, and the telescope doesn't mind that much. And then all that data comes from that camera down to this little rack at the bottom of the pier, and that rack translates the data into fiber optic relay, sends it about 200 feet over to where I am in a nice comfortable office, and where it gets decoded again, so we can put it here on a screen for both of us to see at once for the first time. So this is a live view again. Let's review. See if you guys can remember. Remember what this is? Over here on this left side, Mare what? I know there's going to be a little delay, but see if somebody can type that in. Mare waiting for you guys to say, somebody be adventurous there. Sea of, who's going to remember? Mare, sea of, mare is the sea, the word for sea, M-A-R-E, mare. This one is not, Dave, this is not the fecunditatis. This is sea of mare lunatics. Tiffany, that's hilarious. Now this is the sea of crisis, which we're about to have because we can't remember this stuff. This is Crisium, Mare Crisium. This is Mare Fecunditatis. That Opa guy says, the sea of complacency. This is the sea of fruitfulness, and this is the sea of nectar over here. Now we give way into the sea of tranquility. Apollo 11 right here, Apollo 16 here, Apollo 17 there. Mare Tranquillitas gives way to the Mare Serenitatis, or Sea of Serenity. Up here is the Lake of Dreams, Lacus Sorinorum, or something like that. Now let's work our way down here, this big sea. What will this be? Mare Imbrium. And Mare Imbrium stands for Sea of Showers. Sea of Showers. Here's Archimedes' crater. So here's the Sea of Showers. There's Archimedes' crater. Remember Archimedes? Yeah, all those seas and no water. That's right, Ray. Archimedes was the guy, wasn't he, that... wasn't he the one who discovered... What did Archimedes do? Mathematician and physicist. Did he measure, didn't he discover like how big the Earth was or something? I can't remember. Pupil of Euclid, calculation of pi. He did works in geometry, invented the pulley and the lever, founder of the static and the hydrostatic. This guy was the real deal, man. Tiffany says, water, water everywhere, not a drop to drink. Oh, look, here's Copernicus, too. You're right. Who was that? That Opal guy. Okay, so let's get our bearings here. Mare Imbrium, which was the Sea of... What was Mare Imbrium? Sea of Showers. Mare Imbrium, Sea of Showers. That connects to the Sea of Serenity. These are kind of like the Great Lakes in that they all connect, huh? Mare Imbrium, and then Archimedes is here. Now let's back off a little. This shark's mouth, remember we said the shark's mouth was going to eat the wheel and the Pac-Man. This big shark's mouth, or whale's mouth, is surrounded by this crater, which is Copernicus. So let's go back to our live view now. So this is Copernicus. This is Archimedes. Now what is this little thing here? Is it this? Archimedes. Bam, bam. Archimedes. Yeah, there's a straight row of 3 little craters there. They are Timocharis, Lambert, and Euler. So we're here at Archimedes, and look how we can see that line of craters. Here's Archimedes, and here is something, Lambert, whatever, those 3. But what's this little thing? This is this clearing here with the Montes Archimedes. Turn off the labels for just a second. So that just must be a difference in texture of the surface. Yeah, it's just a difference in texture. We get over here and look how bright and shiny that is. So that's the Boulardus crater. Boulardus. It's named after a French astronomer and historian born in France. So I should be saying Boulialdou. Boulialdou. I got to say that like a crescent roll or something. Okay, so this whole thing is called Mare Insularum, which means Sea of Islands. Well, you can see why they thought they were islands, because they could see little textures there. Sea of Islands. And this was the Sea of Showers. Crisis, fruitfulness, nectar, tranquility, serenity, showers. No. Serenity. Where was showers? Insularum. Insularum must be islands. Where was showers? Maybe Imbrium. Yeah. Oh, I see. So this is Sea of Showers, and then it gives way here to the Sea of Islands. Right here is the Sea of Islands, and this is the Sea of Showers. Sea of Islands, and then to turn the corner, Mare Nubium and Mare Cognitium. Mare Cognitium is the Sea of Knowledge. Cognitium. Mare Nubium is the Sea. Mare Nubium is the Sea of Clouds. Are you guys getting all this? The complacency, the inadequacy, the normalcy. We need a bunch of nuclear-powered rovers and hoppers to explore all these craters. Insular. All right. Let's go back to our landing sites. Apollo 15 landed in the Apennine Mountains. So if we just go up here and put in Apennine, it doesn't find them. A-P, oh, there's only one P. Picky, picky, picky. Apennine Mountains are right here between the Sea of Serenity and the Sea of Showers. So this is where Apollo 15 landed. That was pretty gutsy, wasn't it? They landed right in with all these mountains. Look at that. So here is Conan, like the Barbarian crater, and there is Aratus crater. They landed right here so they could explore those mountains. That Opal guy says, I hope there's no test on these. I won't remember. Tiffany says, Opal, you're not alone. Okay, so there's Apollo 15. Now we swing all around past Copernicus and come over here to Birt crater, and right here is where 14 landed, and then 12 not very far away over toward, halfway to Kepler. So right here between Reinhold and Landsberg. Okay, so let's find Copernicus. So here's Copernicus. And here's Reinhold and Landsberg. So Apollo 12 and Apollo 14 right here. Now look at this giant crater here. So let's back off and get a picture here. This map does not do justice to the rays that are coming out from this crater. If I remember right, that's Tycho, but why am I not seeing it? It just doesn't stand out on this map like it does in the real where it didn't even make it very obvious to us, did it? Where are all the rays? Tycho, show us. Highlight it better than you are. Oh, here's Tycho. See, there just aren't very many rays coming out. If that is indeed Tycho, and I think it is. But look at the live view. It just looks like it's the center of the whole thing, doesn't it? That's the belly button, Ray says. Okay, so let's find it on this map again. You can't even tell it. There's Tycho crater. Now, when the sun is just blasting square on, you don't get a sense of what you might call relief. And you know how the word relief sometimes means things that are raised up at different heights? Look how the map has a sense of like shadows behind these craters. So we're getting a much better sense of relief, aren't we? The relief between the different heights of the crater walls. But look how for us, because the sun is just illuminating square on, pretty much almost from the direction that we're looking, it's like shining a flashlight on it and it's just glaring, and we're not seeing much relief. But like here's Tycho and there's Pitatus, which sounds a lot like potato, but it really means Pietro Pitati, which was a 16th century Italian mathematician and astronomer born in Italy. Now look at Tycho and Pitati. 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 You kind of got to say it like that, don't you? Tycho, Pitati. And then here, look, this is, that's Bouliadieu. Bouliadieu, the French guy, remember? All the way back to Copernicus, back here. Tycho, Pitati, Bulliadir, and Copernicus. All right, now let's work our way down to the South Pole and see if we can find this Malapert. Malapert. Okay, so there's Malapert right there. Now let's look for, see if it can show us Malapert A. There's Malapert A. Now let's take the labels off so we can blink them on and off for a second. So it's right there where that red dot is. That red dot, let me zoom in as tight as they let us. That's as close as we're going to get. That red dot is where the Oddyseus has landed. Let's all do the Oddyseus. This is the new Odysseus dance. It's where the Odysseus has landed. As you know, it sort of tripped and fell over onto, I'm guessing the crater wall. Because if once you look at the way these craters are, what I'm going to do, I'm going to rotate the moon so we can see it a little better. Oh, it's not letting us rotate it around. I need to click this button up here. This button right. Where is that button? Oh, rats. I can't find it now. Ah! No, till then. Where is that crazy button that lets me rotate it around in circles? I want you to know I can't find it. That's so disconcerting. It's right up there on the top of that ribbon somewhere. I'm sure it is. I know it's up there. Okay, so that's the ephemeris. That's notes, CCD field, eyepieces, full screen, second window, Calclin, Weblin, Datlin, picture, Notelin, neighbor, labels, show scale, terminator line, show grid, show libration, show phase. There it is. Okay. So now let's rotate this up. Okay, so once again, look at that crater that lander landed in. See, it's got such, this crater is almost 10,000 feet tall. So 10,000 feet deep. And it's 20 miles wide. So this is a huge crater. Let's click the label on again so you can see where it is. Malapert A. Malapert A. I bet you'll hear English speakers say Malapert A, but it is a French word. It's actually a Belgian mathematician born in Belgium. Malapert A. So that's where the Odysseus is, right there. Now let's go find it on our real map. Okay, so let's get our bearings. Let's put our, now that we learned where that button is, Where was it? I've lost it again. Why is it so hard to find? I should have you guys looking for this. There. Full globe. It's a picture of a little recycling symbol. It's not even a picture of a globe. No wonder I can't find it. It's just two little arrows going around in circles. Okay, so that is going to be at the very, very bottom of what's illuminated. Let's go back to our live view. And let's kick back out here a little bit, put the labels back on. Where was Tycho again? How could we lose Tycho? Is this it? Yeah. Okay, so we're going to find Tycho and then find this big crater. Clavius. Tycho, Clavius, and then Malapert. Malapert. Tycho, Clavius, Malapert. A. Not Malapert, but Malapert A. Tycho, Clavius, then we're going to shoot a little bit off to the left. I mean, it's to the right as we look at it. Okay, so let's go Tycho. So this must be, is that Clavius or is that Clavius? Let's get our bearings. Here's Copernicus. Copernicus, Tycho, Malapert. It's a straight line for Copernicus. Copernicus, Tycho, right down here. Copernicus, Tycho. So that must mean that this is Clavius. Right here is Clavius, and right down here is the South Pole. See where all those deeper rills are, deeper. There's a lot of atmospheric disturbance, but right down here, Clavius. Copernicus, Clavius, right there. So that shadow. Copernicus, Clavius, and that shadow actually a little bit, is that east? A little bit east of that shadow. Copernicus, Clavius, Malapert, right here. So that's the South Pole. What do you guys think? Fun, huh? Corin, good to have you on from foggy London. Just catching up on all your, my goodness, you guys have been active over here. It will be fun if they can land near the pole. Tycho's the belly button. Would have been fun to see that impact. Topography is not great at full moon. If you saw moonfall, you know it's just the light reflecting from all the inner structure. Good luck picking that spot out. You like it when there's a terminator. You can see the shadows. Can't imagine the Bortle number on the moon. It's so bright. You're right. It's a Bortle 4. Bortle is great on the dark side. I hate how small interface buttons are on software. You and me both. The decision-making process for picking these landing sites. Good point, Tiffany. Well, see, they wanted a crater that's real deep. Remember we said it's like, what did we say? Did we say it was it 2,000 feet deep? $10,000 feet deep and 20 miles wide. So because it's 10,000 feet deep, it means the sun never hits the bottom of the crater because of the fact that the sun is always hitting this side. Because of the way this side is tidally, it's like the tides, it's attracted to the earth, and the way it spins, the sun never illuminates that South Pole crater. Wait, no, the sun does hit the other side, doesn't it? Yeah, it just doesn't hit at the bottom because the moon stays upright with the orbital plane. So the sun is always glancing off the bottom. And because this crater is so deep, that's why they hope there's ice in the bottom. And we can turn the ice into water and the water into hydrogen for fuel and water to drink. You guys know this already. Let's see. The Opal guy says, if you had told me 20 years ago that I would be watching someone looking at the moon with a telescope on the internet, he says, I would have laughed. That's true. Right below or to the right of Moretus. Let's go over and find Moretus. How did you know this, Jeff? Moretus. Moretus. Right. How did you know this? You guys are talking about how great it would be to have the telescope on the moon. So there's Moretus, and then right below it is Malapert. Malapert. So there's Malapert, right below Moretus, just like Jeff said. And Malapert A is literally right below Moretus. So there's Tycho, Clavius, Malapert A. A little bit to the east. Copernicus, Tycho, Clavius, Malapert A. Right here. I suppose in maybe 4 or 5 days, that'll be even clearer down there if we have good weather. But tonight was the only clear night I saw coming up. All right, let's go back to our observing software and let's pick out all the different things that are on our observing software that we're supposed to observe in the Cosmic Challenge. First of all, there's something called Lunar 5. What is Lunar 5, pray tell? Let's go back to our map. Lunar 5, Roman numeral 5. It didn't find it. That's not good. Lunar 5. It didn't find it. We're going to have to go to the... Okay, so the Apollo landing sites, we found all of those. Check. Lunar 5 is Object number 79. Okay, so it says an X floating in the darkness. What? Lunar V. So it's not Lunar 5, it's Lunar V. Lunar X and Lunar V. The so-called Lunar V is formed by low-angled sunlight spangled across several small craters. Oh, I see it. Okay, so let's find Oort crater. That might be Oort. Let's see, Oort. You know, when it shows us a crater, it just doesn't make a big enough deal about it. Where is it? I don't see it. Point it out. Somewhere on this, tell you what, let's turn off this. And, there, that's the way you do it. You have to turn off all the other labels. Okay, so there's the V. If you find Oort, let's see what, oh, he's German. Oort. He's a German historian and philologist born in Germany. Friedrich Oort. It says this bright crater, 14 miles in diameter, situated in the region of northeast of Triesnecker, is surrounded by a very complicated arrangement of mountains, and on the north and west is flanked by other enclosures, has a distinct central mountain. Its most noteworthy feature is a great valley more than 80 miles long, which extends from northeast to southwest on the east side of it. Okay, and right here is the Lunar V. Okay, now how are we going to find this? Let's put our labels back on. Here's Copernicus. And there's Tranquility Base, Tranquility, Sea of Tranquility. So in a direct line between the Sea of Tranquility and Copernicus. Okay, so we're going to go back here. Here's Copernicus. Here's the Sea of Tranquility on a direct line between so these mountains Mare Orientale here. Anybody see it yet? Corin wants us to send clear night skies to London. I don't know if we can do that over the internet yet. Okay, so let's get our bearings here. Copernicus, Archimedes, Oort form a kind of triangle. Copernicus, so this is Tranquility. And Euclid is right here. So here's Tranquility. Here's Copernicus. So this crater must be Lacus Lenitatis, which is to say Manilius crater, 1st century Roman poet born in Rome. This must be two craters side by side. Yeah, there are the two. See those two craters there side by side? That's these two. Now, where's the V again? Oh, right here. So between Copernicus and these two craters, Copernicus and these two craters, there's a little Valentine heart. That's pretty cool. Murchison. There are those two craters. Mare Vaporum. Two craters. There's a little clearing here, isn't there? Two craters. Here must be that little clearing. It's right there. Is that Euclid? So that's the V. In this lighting, it's not showing up as well. We need lighting that cuts across it to make more relief, don't we? So I'll have to come back to that. I'm going to say here, my goodness, so many choices. That's too hard to pick out. Observation. I'm going to say, we saw the location but lacked the relief, the light cutting across the V. Ray says the Lunar X shows up nice at half moon. I bet you're right. Right on the terminator. So I bet we'll have to come back to it as well. Let's at least find the location of the X. So to find the X, we're going to look for La calle. That sounds like the street in Spanish. La C-A-I-L-L-E. It really means, it's a name. Nicolas Louis de la Caille, French astronomer born in France, 1713. He created several new constellations. First precise measure of lunar parallax. Okay, so let's get rid of all these labels so we can find Le Caille. Where's the red mark? Not seeing it yet. Anybody seeing the red mark? Oh, here it is. Right here. Okay, so let's zoom in on that. So Le Caille is the top part of the X. So it's like 5 craters. Le Caille, Blanquinus, Werner, Regiomontanus, and Purbach. So at the intersection of these craters is an X. You kind of can see it, can't you? Even though the relief's not perfect. Okay, now let's find it in real life. This is our landmark Copernicus. This is Tycho. Copernicus, Tycho. And then we go over to here, right? Werner. Yeah, so it's like a check mark facing in the direction of the Sea of Tranquility. Okay, so here is Copernicus, Tycho. So that X is going to be right here. But again, there's not enough relief. We'll have to come back to it when it's like Ray said, half moon. Once again, we found the location, but the lighting isn't quite right until Ray said half moon. Okay, let's go to Birt A and Rima Birt and Birt Banded crater, which is beside Rupes Recta. Back to the map. So we're going to look for Birt Banded crater. Didn't find that. Let's try Birt A. You found it. There's Birt A. This is number 83. Let's read what in the world does it mean here. 83. Oh, Rupes Recta means straight wall. And Rima Birt, what is your favorite lunar feature? Maybe it's the mighty craters Copernicus or Tycho. Or could it be the historic Sea of Tranquility? Perhaps you enjoy visiting the rugged southern highlands around Clavius, or the Apennine and Alp Mountains. If I had to come up with my favorite target, it would have to be a far more modest site. I always enjoy looking for and at the straight wall. Best seen 8 days after new moon, and again on day 22. The straight wall is listed more properly under its official name, Rupes Recta, or straight fault. While fault lines on Earth are most often associated with plate tectonics, Rupes Recta was formed when a portion of Mare Nubium succumbed to subterranean pressures in the lunar crust and buckled. The area to the west of Rupes Recta sheared off and dropped some 1,000 feet along the fault line that extends for 70 miles from tip to tip. So it looks like a sharp, dark line or a bright scar. Rupes Recta. Oh, right there it is in our map. Look. See, there's Rupes Recta. Right in front of Birt A. So to find this, we can go from Copernicus down to Pitatus. From Copernicus to Pitatus, which is in line with Tycho. And then look out in this Mare here, which is called Wolf? No. Mare Nubium, which means clouds, maybe? Boy, there's a crater right on top of the word Mare Nubium. And I keep anyway. Copernicus, Pitatus, Mare Nubium, Rupes Recta, that's the straight wall. There's Pitatis, here's Copernicus. I guess because the lighting is straight on, it's just invisible, right? Copernicus, Tycho, Pitatis, Copernicus, Pitatis, Rupes Recta, Birt. It's just right out in that sea. There's nothing. Oh, I think I see it right here. Yeah. You can barely make it out, huh? It's a line, but it's not really very colorful. But you can see that it is straight. Yeah. And there's more clearing behind it. And then there is Birt A right here. Well, we'll know where to look for it next time. You guys. Quite a bit of latency developing in our astroplanar over here. Oh, there, it came alive when I hit that plus. Again, lighting isn't quite right in full moon. See, there's a little bit of latency there. The words just kind of come one step at a time. What about, now that you guys have been on for a while and you've sort of watched the screen, do you have an opinion about the difference in the, I was using, what do you call it, like night vision? Guess I need to change this. Welcome to full moon observation night. Okay, checking off all these Apollo sites. We've already taken note of those. The next thing on the list is Clavius, and we saw Clavius a while ago. Unless it does this, you don't get a market, I'm seeing. Like if you just click here, you don't wait for that little box to come up. That's odd. Yeah, doesn't mark it as observed until you do that. I still like this better. It's just, it does get rather latent. Okay, Clavius. Let's back off here. Boy, I already feel like we know the moon better than I ever have in my life. I mean, isn't it amazing what one night's difference will make? Dennis likes the night vision screen. This is too bright. Well, I thought it was brighter, but when I read about this on the web, it said that night vision was actually, you had to focus more. It took more stress on your eyes. So I don't know, man. Okay, back to our map. We got to find Clavius. Let's take our labels off. It's actually down there near Oddyseus. Yeah, here's Clavius. So here's Pietatis, there's Piatis, there's Tycho, and there's Clavius. So let's go back to the live view again. So here's Pietatis, Tycho, Clavius. So there's some, what you might call eject, you know, what do you call that? Ejectile, or where there's been some rocks that have thrown up. It says Clavius's Crescent of Craters. Boy, that's a mouthful. Say that 6 times real fast. Clavius's Crescent of Craters. This is object 76. Clavius's craterlets. Oh my goodness. One of my favorite lunar landmarks is monstrous Clavius. So down here, it is huge, isn't it? Look. It is big. It spans 136 miles from edge to edge, and around the 8th day past new, as well as day 22, the night after last quarter, on these nights, sunlight just catches the top of the rim, causing a bright ring to protrude into the cold, dark lunar night. Clavius is a relatively old formation. It's riddled with more than a dozen small craters. Let's go look at the map and see those. There you go. Look at that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 I saw just then. And then here are a couple of other smaller ones over here. Look at this kind of like a arc. And it opens up to the South Pole. Yeah, it's kind of hard to see those when it's full moon, isn't it? So it would be like that. Pretty interesting, though. It's a crescent of craters. Yeah, it is an arc. Clavius's Crescent of Craters. I wish there was a way we could get that secondary screen that we didn't have to use it. I'll look into that. Okay, the next thing is Mount Hadley. Let's go back to our map. And look up the word Hadley. I actually have a granddaughter named Hadley. How about that? This is my granddaughter's right here in the middle. Hadley C. Mons Hadley. Mons Hadley. Oh yeah, look at that. We're already zoomed in as tight as we can go. So this is our friend Archimedes. Remember, this is Sea of Tranquility. Mons Hadley is object number 127. Mons Hadley and Rima Hadley. On July 30th, 1971, Commander David Scott and pilot James Irwin navigated their Apollo 15 lunar module, nicknamed Falcon, to land among the lunar Apennine Mountains, while Alfred Worden remained in orbit aboard the command module, Endeavour. Scott and Irwin guided Falcon to a soft landing between the edge of a deep precipice and the base of a tall mountain. The remains of Hadley Base, as the landing site became known, may be invisible through our telescopes, but its spectacular surroundings are a must-see stop on any tour of the moon. Follow the curve of the Apennines toward their northern end, where to the east lies a flat area known as Palus Putredinis, the Marsh of Decay. Just west of the marsh, in the lunar highlands, is the prominent peak Mons Hadley. Hadley rises an impressive 14,500 feet. What? That's 3 miles. That's half the height of Everest. Look carefully just to the east-southeast of Mons Hadley. Oh, for a thin, sinuous channel that snakes through the adjacent flat plain. That's Hadley Rill, or more accurately, Rima Hadley. You see it? Right here is Hadley Rill. Okay, let's go to our live view. Okay. So, tranquility, serenity, showers. Tranquility, tranquility, serenity, showers. So between serenity and showers, find Archimedes right here. Between serenity and, oh, over here. Yeah, right here's Mount Hadley. Copernicus, the Apennines. See, from Copernicus, right here, follow the Apennines almost to the end. From Copernicus, follow the Apennines almost to the end. Right here. Mount Hadley, right there, and the rill here's Archimedes. The rill would be out here with this direct lighting. It's just not very plain. Wow, taller than the Matterhorn. Clavius, Crescent of Craters. Say that fast 3 times. Mount Marion. Doug, I guess it's not a coincidence that your granddaughter's name is Hadley. I guess probably named after the moon, huh? All right, so again, we have to come back in different relief, but we at least have found the location of these. But it's kind of stretching it, saying we saw that rill, the Rima Hadley, isn't it? The farther we get, the more latency is built into our Mount Hadley. Yes. Rill, not really. Not really. Not really. Okay. I don't know why I don't know why they would have picked Hadley. I guess it just sounded good to them. I don't think it's named after the formation of the moon. Do you guys know, I've lived my whole life, my entire life, and in the last 2 hours, I've learned more about the face of the moon than I have the entire rest of my life. Isn't that criminal? Why didn't I learn this stuff before? So sad. Okay, the next thing is supposed to be the Sea of Margins. What is that? Mare Marginis. It's number 80 on the list. Mare Marginis. Mare Marginis. You know, this atlas is pretty handy, isn't it? I'm going to have to turn off labels again to see where this thing... Oh my goodness. Look, it's way out there on the edge. Oh, I get it now. I get it. Margin, right? Number 80. Oh boy. Many lunar features living on the edge of the moon's far side can be seen from Earth thanks to libration. Challenge 80 offers up 2 lunar maria that live on the edge. They both take a little extra effort to spot, but with the right timing, each can be spotted through even the smallest astronomical telescope. The first, aptly named Mare Marginis, which means sea of border. Lies between Mare Crisium, remember that's the Sea of Crisis, and the Lunar LEM. The oddly shaped lava plain measures some 420 miles across. If the libration is especially favorable, swirls of strange brighter material can be seen within Mare Marginis. These odd features, first noticed in photos taken during the Apollo lunar mission, seem to coincide to magnetic anomalies discovered during those same missions. This sounds like aliens, you guys. The Ferengi renamed that one Opal. Spotting the Marginis swirls, take a careful eye looking under just the right lighting and libration conditions. The best opportunity comes when the moon is just 2 or 3 days past noon. You guys know what libration is? It's like because the moon wobbles a little bit. Because it's wobbling, we actually get to see more than 180 degrees of the moon. We get to see it when it's wobbling. So I think by the time we're done, we get to see like maybe 55% of the moon instead of just 50%. Because you guys know, remember, there's this one side of the moon that's always facing us, always, because it's locked in a dance with the Earth. But because it wobbles a little bit, libration, we see more, depending on what part of the wobble it is. If you can see Mare Marginis, look along the limb to its south for another grayish smudge. That's Mare Smithy, named for British astronomer William Henry Smith, author of the landmark 19th century observing handbook, the Bedford Catalogue. His namesake Mare measures some 450 miles in diameter, shows an unusual two-tone floor. While the tone in most Mare appears homogeneous, Mare Smithy has a lighter central area bordered on either side by darker lava. The darker portions are believed to be younger, perhaps 1 to 2 billion years younger than the lighter central portion, which might date back to 3.5 billion years. Okay, according to our map, which is supposed to be tuned to the date, I don't think we're going to see very much of this. There is this thing called Sabatier, a French chemist. It's a circular formation with a bowl shape, slightly steep slopes. But boy, to get all the way out here, I mean, you can barely see it on the map, so, and the map is supposed to be synced. Let's call it up one more time. Mare Marginis. Yeah, it's off in the black, so I doubt we'll be able to see this. But let's get a sense of where it is anyway. Okay, so remember this was nectar. This was fruitful. This is what was it? Rats. Tranquility, fruitful. Oh, crisis, yeah. So we're going to go out from that. Okay, let's go to the live view. Nectar, fruitful, crisis. Way out here, there's a sea. Now look, right there, there's a little thing opening up. It's like a crater opening up. Right on the very edge. Look, there's a nice big crater thing opening up. What is that? That would be in line with fruitful, crisis, and that crater. Fruitful, crisis. So we're seeing like maybe this. Plutarch. So that's probably Plutarch. But maybe there's a little bit of an opening here. Might be this bowl thing. Hansen. Okay, so if I turn this switch, remember it doesn't look like a globe. It looks like a recycling symbol right here. Now we can spin it. So there is nectar, there is fruitful, there is crisis, This looks like a Mickey Mouse. Look, there's the two Mickey Mouse ears. This is the Sea of Mickey. What was it called? Marginis? Mare Marginis. Okay. So right there on the terminator, you know, we can always depend on the fact that it's going to be visible again because you know what Arnold said, I'll be back. The Terminator will be back. So I want to see this Mickey Mouse here. Sabatier, Hansen B, and Alhazen A. Make a Mickey Mouse. I wonder if anybody's ever reported that before. Formation on the moon margin near Goddard, near formation on the moon margin made up of 3 craters, Alhazen, Hansen, Sabatier. Looks like Mickey Mouse. Mickey Mouse on the moon. Oh, yeah, look. People have seen several, but it doesn't look like they've reported this particular one. Nope. Guys, we discovered a new formation tonight. It's Mickey Mouse 2. Okay, so we really didn't see Marginis. What about Orientale? Wait, let's lock this thing back. Oh, rats, our time is gone. Orientale. Orientale. Why didn't it find that? Mare Orientale. There we go. Where's the red dot? Can't find the red dot. Does anybody see it? You need to make their dots bigger. Sorry, I don't mean to complain, but where is it? Must be. Anybody see it? You guys don't see it either, huh? Nope, I don't see it. Anyway, 81. It's got to be our last object, guys. Oh, Mars, it's on the very edge. It might not even be visible tonight. I bet that's the case. Let's turn this silly button off that I can never find. Where is it? There we go. Oh yeah, there's the red dot. It's right behind the blackness. So that's not the right time for us anyway to see this. Mare Orientale. Unless that red dot is in the middle of it. Yeah, I bet that's in the middle of it. It's the most recent impact basin on the moon's surface. It's centered 5 degrees beyond the edge, so we never get to enjoy the full effect. How about that? Lunar libration must line up with the correct lunar phases for any hope of seeing this challenge. Well, let's take our little switch back off. Now that we know where to look. Okay, so this is Copernicus, Bouliades, Kepler. Copernicus, Kepler, Gassendi, so this must be this. Look at that basin there. That's pretty cool. Grimaldi. Very dark circular, resembling to a sea. Steep slopes. Look at that. Okay, so now if we can get Mare Orientale back. Rats, beyond the edge again. We lost it. And I lost that silly button again. There it is. Right here. Yeah, so it almost lines up directly with this. So see how it's kind of a little, oh wait, down here is where it is. Boy, we see nothing of any dark patches. Just not the right time of because this circle is that circle. So it would be out here along this edge. Not seeing it. Orientale, right. All right, well, let's back off here and take one last look. We spent a lot of our time here tonight on the moon, haven't we? But remember, part of the reason was because this is the way the sky looks tonight. It's just crazy how much that moon dominates the night for us. So I thought it was fitting, in the spirit of if you can't beat him, join him, for us to start giving this a whirl. And I do feel like we made a dent in it. Now we know this is crisis, fruitfulness, nectar, tranquility, serenity, showers, and I forget this one. This is Tycho, Copernicus, I mean, we learned a lot, and I guess here is that new one we just learned. What was that called? This, Grimaldi. That sounds like something from Charlie Brown. Grimaldi. That's Grimaldi. The guy that did the music for Charlie Brown. Vince, forget his name. Hey, if you guys like crazy content like this, lunatic content, as some of our co-astronomers here have told you, then I wish that you would subscribe. We have a lot of folks that watch the video that don't subscribe. And if you like it, and only if you feel comfortable doing it, honestly, you can click thumbs up and it doesn't cost you anything, and that helps it come up in the windshield of everybody else. You could also subscribe. You could click the bell, and that way the bell will notify you. Usually we tell you like the day before or the day of, like 12 hours in advance when we see it's going to be clear. We tell you. I wish you guys would do that and be a part of this unique family that we have. Tiffany says, thank you so much for such a lovely evening, everyone. Stay well. See you next time. Blessings to all. Dean says, Plato, randomly. That must be one of the other craters. Vince Giraldi. Thank you, Jesse. Vince Giraldi. Jeff says, that was great. Would love to do it again. We'll have to catch it when the Terminator's in a different place. We'll see this X and the V and all. Vince Giraldi. Dave, thanks for the encouragement, saying it's a good show tonight. That Opa guy says, have a good one to Tiffany. Tiffany's just the one that everybody likes. Let's face it. I'm only here as just sheer, I'm like the curtains on the back of the stage. It's really all about Tiffany. Let's face it. It is. You guys have a great evening. Thanks for sticking with us. And the next clear night, we try to do one of these a week if we can. We'll see you soon. God bless, and thanks for being with us on a unique night. But this was part of the challenge that we needed to do anyway, the cosmic challenge. We had to do these on the moon. So we'll be back, and we'll look forward to seeing you next time. God bless. Good night.